If you were standing on a small asteroid and the gravity was weak enough, would it be possible to jump into orbit? Well, I am standing on a small asteroid. The gravity here is very weak indeed. So let's give it a go. I'm out in the asteroid belt and standing on, well, I suppose you'd call this a medium-sized asteroid. The gravity here is very weak. If I push even slightly with my foot, it'll send me about a meter or so up into the air. First, let's look at the asteroid I'm on. It's about 1 kilometer across and is made of a mixture of nickel, iron and rock. But it's the gravitational strength that we're really interested in. The gravity here is much weaker than on Earth, about 4,000 times weaker. This means that my total weight, including my suit and equipment pack, is only about 30 grams. That's as much as a sparrow weighs on Earth, so there's really very little force holding me onto the ground. To get into orbit around the Earth, you need to be moving around 8 kilometers per second, but here, with the gravity so weak, the speed needed is only 1.1 meters per second. Anyway, I think it's time to have a jump. Obviously, launching myself straight up won't put me into orbit, so I'll have to lean forward and launch myself at an angle. Okay, this is looking good, so here goes. And my speed over the ground is 0.8 meters per second, and that won't be enough to stay in orbit. My height's increasing at the moment, but eventually I'm going to come down. Even this suborbital jump will take a few minutes to complete, so let's fast forward to touchdown. Well, I've been descending for some time now, and I can see the point where I think I'm going to touch down. I say touchdown, land on my face more like. I've rotated a bit during my jump, so this isn't going to be a graceful landing. I'm just going to face plant. Okay, so that didn't work, but I knew that from the start. I just wasn't going fast enough. Let's have another go, and this time jump a bit harder. Right, let's try that again, and this time I'm going to use a bit more force. In this super low gravity, leaning forward takes some time. As well as launching at a lower angle, I'll try to make it a faster jump. Nearly there, and blast off. Okay, that feels a bit faster, but let's wait till I've got a speed reading. And here it is, 1.21 meters per second, and that is just about perfect. At this speed, it'll take about 40 minutes to complete a full orbit. Let's fast forward and see if this has worked. I've gone most of the way around the asteroid now. In fact, I think I can see my start point, but I'm clearly heading towards the ground. So this attempt didn't work either. Let's touch down and then I'll explain what went wrong. Unlike my last landing, this time I'm touching down on my feet. A perfect landing? If only. I stumble, I roll, and I'm back off the ground. Okay, let's pretend that didn't happen. So, that attempt didn't work either. But why? My launch speed was perfect. If I'd launched any harder, I'd have escaped orbit completely. So why did I end up back on the ground? It's because of the way orbits work. As soon as my feet left the ground, I was in an elliptical orbit around the asteroid's centre of mass that would keep going round and round until I bumped into something. And that's the problem. Because I launched from the ground, my orbit would eventually bring me back into the ground. So it turns out that you can't jump directly into orbit from the ground. To get into orbit and stay there, I'm going to need a little bit of help. Okay, third time lucky. I'm going to repeat my last jump, same direction and hopefully the same speed, but this time I've got this. Yep, it's an ordinary CO2 fire extinguisher, or as I like to call it, a rocket propulsion system. I'm going to use this to alter the speed of, well, let's just get launched and I'll explain when I'm on the move. My third jump was almost a carbon copy of the previous one, so we'll go straight to the halfway point. This is where things should get interesting. I'm halfway around my orbit and at the highest point above the ground, and my speed has dropped to 0.8 meters per second. As we've seen, this orbit will eventually take me back into the ground. But this is where the rocket science comes in. I'm going to give a good blast on this fire extinguisher, pointing the nozzle back the way I came, and this should propel me forward and increase my speed. I'm not pointing in the right direction yet, but a quick off-center blast should rotate me around, get me pointing in the right direction. Okay, this is looking good, so time to do my main burn. Careful aiming of the nozzle keeps me blasting in the right direction, doing a so-called pro-grade burn. That seemed to work okay. The aim was to increase my speed, which has now risen to 0.9 meters per second. That might not sound like much, but it should be enough to fix my orbit. Here's what happened when I made the orbit correction. By doing a prograde burn at the highest point of the orbit, it raised the lowest part of the orbit, making my path a bit more circular. Let's fast forward and see if this has worked. I'm approaching the lowest part of my orbit, or periapsis to use the technical term, and my speed has increased to 1.22 meters per second, so this is the moment of truth. If my course correction worked, then I'll get quite close to the ground, but won't actually hit it. Getting closer, I can see my starting point up ahead. I seem to be upside down, but that's no problem. And yes, I think I've made it. I'm only a few meters off the ground, but that's enough. If I was going to land, it would have happened there. So there we are. To answer the original question of this video, can I jump into orbit? Well, almost, but not quite. Without the help of a little bit of rocket science, I just end up colliding with the ground again. But now there's a new question on my mind. About 3 kilometers away, there's another small asteroid. It's actually in orbit around this one. So the question is, can I jump from this asteroid across to that one?